Humanity has always been drawn to the stars. The vast expanse of the universe has always sparked our curiosity and imagination. For centuries, we have gazed up at the night sky and wondered about our place in the cosmos. The twinkling lights above have inspired countless stories, myths, and scientific inquiries. Among the celestial bodies that have captivated our imagination, Mars holds a special place. Its reddish hue and mysterious surface features have made it a focal point of our dreams and aspirations. The Red Planet, as it is known, has beckoned us with its promise of adventure and discovery. The idea of exploring Mars has fueled the ambitions of scientists, engineers, and dreamers alike. Today, the dream of sending humans to Mars is closer than ever before. With advancements in technology and a renewed interest in space exploration, the once distant vision is becoming a tangible goal. But before we can set foot on Martian soil, we must develop the technologies and strategies that will allow us to survive and thrive in this alien environment. This involves rigorous planning, testing, and innovation. One of the most critical challenges we face is designing and building habitats that can protect and sustain human life on the Red Planet. These habitats must withstand harsh conditions, provide life support, and ensure the safety and well-being of the astronauts. Scientists and engineers are tirelessly working on creating sustainable living conditions on Mars. From developing advanced life support systems to ensuring reliable sources of food and water, every detail is being meticulously planned. Robotic missions have already paved the way, providing us with invaluable data about the Martian environment. These missions have helped us understand the challenges we will face and the resources we can utilize. The vision of a thriving human colony on Mars is no longer just a dream. It is a goal within our reach, a testament to human ingenuity and our unyielding desire to explore the unknown. As we stand on the brink of this new frontier, we are reminded of the boundless possibilities that lie ahead. The Red Planet dreams are becoming a reality, and the journey to Mars is just the beginning of our next great adventure. Mars presents a formidable challenge to human exploration and habitation. Its thin atmosphere, composed primarily of carbon dioxide, offers little protection from the sun's harmful radiation. Temperatures on Mars can fluctuate wildly, plummeting to bone-chilling lows during the Martian night. The lack of a global magnetic field like Earth's leaves the planet vulnerable to solar flares and cosmic rays. These harsh conditions necessitate the development of innovative habitats that can provide a safe and habitable environment for future Martian explorers. When designing habitats for Mars, engineers and architects must prioritize several key factors. These considerations are essential to ensure the safety, sustainability, and comfort of future Martian inhabitants. First and foremost, the habitat must be airtight and capable of maintaining a pressurized atmosphere with breathable air. This is crucial because the Martian atmosphere is thin and composed mostly of carbon dioxide, making it inhospitable for human life. It must also provide adequate shielding from radiation, both from the sun and from cosmic rays. Mars lacks a magnetic field and thick atmosphere, which on Earth protect us from harmful radiation. Without proper shielding, prolonged exposure could be detrimental to human health. Temperature regulation is another crucial consideration, as the habitat must be able to withstand the extreme temperature swings on the Martian surface. Mars experiences temperatures ranging from a balmy 20 degrees Celsius during the day to a frigid minus 125 degrees Celsius at night. Additionally, the habitat should be designed to utilize local resources such as Martian soil and ice to reduce reliance on supplies from Earth. This concept, known as in situ resource utilization, can significantly lower the cost and complexity of Mars missions by making use of the materials available on the Martian surface. Numerous concepts and designs for Mars habitats have been proposed over the years, each with its own advantages and drawbacks. Some designs favor modular structures that can be easily transported and assembled on Mars, while others envision larger, more permanent habitats constructed using Martian resources. Many designs incorporate inflatable modules, which offer a lightweight and compact solution for transporting large volumes of living space to Mars. Regardless of the specific design, all Mars habitats must address the fundamental challenges of radiation shielding, atmospheric control, and temperature regulation. Section 5. High seas. simulating life on Mars and Hawaii. This unique project is designed to mimic the conditions that astronauts might experience on the Red Planet. To prepare for the challenges of living and working on Mars, researchers have developed terrestrial analogs, or simulated Mars environments here on Earth. These environments are carefully crafted to replicate the Martian landscape, atmosphere, and isolation. One such analog is the Hawaii Space Exploration Analog and Simulation, or High Seas facility, located on the slopes of Mauna Loa volcano in Hawaii. The location was chosen for its remote and barren landscape, which closely resembles the surface of Mars. This isolated habitat serves as a testing ground for studying the psychological and social effects of long-duration space missions. Researchers monitor the crew's mental health, stress levels, and group dynamics to understand how isolation and confinement impact human behavior. Crews of volunteers live and work inside the high seas habitat for months at a time, conducting research and simulating the tasks and challenges that future Martian explorers will face. These volunteers perform daily routines, scientific experiments, and even emergency drills, all while being cut off from the outside world. Their experiences provide valuable data that will help pave the way for successful human missions to Mars. Section 6. Mars Desert Research Station, a Red Planet outpost in Utah. Another prominent Mars analog is the Mars Desert Research Station, or MDRS, located in the remote Utah desert. Operated by the Mars Society, MDRS provides a unique environment for conducting field research and testing technologies for future Mars missions. The station consists of a habitat module, a greenhouse, an observatory, and other support structures. Crews at MDRs conduct geological surveys, test spacesuit prototypes, and experiment with growing food in Martian simulated conditions. Section 7. Testing the technology. Life support systems for Mars. Developing reliable life support systems is paramount for ensuring the survival of future Martian colonists. These systems must be able to recycle water and air, generate oxygen, and remove carbon dioxide. They must also be energy efficient and robust enough to operate reliably in the harsh Martian environment. Researchers are exploring a variety of technologies, including advanced filtration systems, hydroponic gardens, and oxygen-generating equipment to meet the life support needs of future Martian inhabitants. Section 8. Growing food on Mars. The challenge of Martian agriculture. Establishing a sustainable food supply will be essential for long-duration missions to Mars and eventual colonization. Growing crops in Martian soil, which lacks essential nutrients, presents significant challenges. Researchers are investigating techniques such as hydroponics, aeroponics, and the use of Martian regolith as a growing medium. They are also experimenting with different types of crops that may be suitable for Martian agriculture, such as potatoes, lettuce, and soybeans. Section 9. The human factor, psychological aspects of long-duration missions. Beyond the technical challenges, long-duration space missions also pose significant psychological and social challenges for astronauts. Confinement, isolation, and the stresses of living and working in an extreme environment can take a toll on mental health. Researchers are studying the psychological effects of long-duration missions in analogs like high seas and MDRs to develop strategies for maintaining crew morale and well-being during future missions to Mars. Section 10. From prototypes to reality, the path to Mars colonization. The prototypes and simulations being developed today are paving the way for future human missions to Mars. By testing technologies, conducting research, and gaining experience in simulated Martian environments, we are steadily overcoming the challenges of interplanetary travel and habitation. As our understanding of Mars and our capabilities for space exploration continue to advance, the dream of establishing a permanent human presence on the Red Planet is becoming increasingly attainable. Section 11. Conclusion. Building a future on Mars. The journey to Mars is fraught with challenges, but the rewards are immeasurable. By pushing the boundaries of human ingenuity and exploration, we are not only expanding our scientific knowledge, but also inspiring future generations to reach for the stars. The development of innovative habitats and technologies for surviving and thriving on Mars is a testament to our determination to explore new frontiers and secure humanity's place in the cosmos.